The major limitation in Bernoulli's theorem is the fluid which is used is ideal or frictionless and incompressible. So only forces present are the pressure force and the gravitational force. And next limitation is the fluid is steady and continuous. It is also one dimensional flow. But in actual condition, this is not the case. First, we shall go with the real fluid, that is loss of head in the real fluid here. The loss of energy that is wasted in the real fluid is due to frictional effect per unit weight. That means in the walls of the fluid or side, sometimes there might be obstruction, there will be a loss of head. That loss of head should be encountered in the Bernoulli's equation. Now writing down the Bernoulli's equation for section 1 and 2, that is a convergent cone here. What I have taken, it is P1 by rho g plus V1 square by 2g plus Z1 is equals to P2 by rho g plus V2 square by 2g plus Z2. Now coming to this, here what happens in the fluid which is flowing from section 1 to 2, due to the friction between the molecules and on the surface of the walls, on the surface of the walls, so there will be loss of head. That loss of head should be encountered in the Bernoulli's equation. It is written as HL. That is loss of head due to friction in pipe. That means here this whatever the total head we have, total head is nothing but the P by rho g plus V square by 2g plus Z will not be the same at this point also. There will be some losses if the fluid is flowing from section 1 to 2. There will be some loss of head due to friction in pipe. That loss should be encountered at the section 2. Now similarly for the turbine. Now coming for the turbine, if I write the Bernoulli's equation here, that is P1 by rho g plus V1 square by 2g plus Z1 is equals to P2 by rho g plus V2 square by 2g plus Z2. Here now coming to this, due to the insertion of the turbine, right, here the section 1 and 2, there will be a turbine which absorbs the head loss, which is located in between the section 1 and 2. With this I can write the head loss is there due to turbine. This head loss is nothing but the loss of head due to a insertion of turbine in between section 1 and 2. If this is the downstream and the upstream, it is in between the downstream and upstream. So the loss of head due to insertion of turbine should be written at the downstream of the fluid, that is at section 2. Now, similarly, if we have a pump, which is located in between section 1 and 2, pump should suck the fluid from section 1 and it should flow through the section 2. So the Bernoulli's equation becomes here is P1 by rho g plus V1 square by 2g plus Z1 is equals to P2 by rho g plus V2 square by 2g plus Z2. Here pump, it should be subtracted from the section, it should be added at the section 2 here, that is loss of head due to pump here, because it is creating a vacuum here. There will be loss of head due to suction, right? That means at the section here there will be some losses due to suction in the pipe. So that loss should be encountered in the total head of the section 1. Right? This is how the thing what in a real application works, that is a real fluid flow works. Thank you.